Welcome to the deep dive. Today we're tackling something, well, fundamental really, to understanding the tech that's shaping our future, artificial intelligence. And we're not just rehashing old definitions, we're diving into an updated proposal from Dr. Georgios Fradelos, a definition that's really designed to sharpen our thinking about what truly counts as AI today, in this incredibly fast-moving world.
Exactly. I mean, the landscape is just shifting so quickly. What we thought was cutting-edge AI maybe just a few years back, now it might just look like sophisticated software. And Dr. Fradelos, he brings a really practical view. Given his background, you mentioned management, AI in finance, going way back to 2010, sustainable finance, his own AI tech.
Right, the GF-ACCORD tech.
Yeah. So he's got this grounded perspective, and his point is crucial, like you said. What counts as AI today may not count as AI tomorrow. It's a moving target.
Right. He's not just some theorist in an academic bubble. He's actually been there, applying AI in complex financial situations. So our mission, really, in this deep dive is to unpack this updated definition he's put forward, understand its key parts, and probably most importantly, figure out what it all means for you.
Okay, so let's get straight to it. The core definition. Dr. Fradelos says AI is any piece of software that analyzes and/or generates data. And that includes data for its own training, which is interesting, and can routinely produce with only exceptional human intervention. And then he lays out three possible outcomes.
Okay, right. Three possibilities. Let's unpack those. Option one is producing better results for analysis and/or synthesis tasks than the average human professional today in the same professional culture for qualitative results independent of energy cost.
Okay, that's quite a mouthful, but it feels important. What really jumps out at you there?
Well, the key bits for me are better results, and specifically for qualitative results. Think about tasks needing, human judgment, creativity, that kind of nuanced understanding, complex strategy maybe, or generating really creative marketing ideas.
Exactly, stuff like that. And what's really fascinating is how he explicitly says independent of energy cost for this first option. It sort of suggests that initially, anyway, the big goal might just be breakthroughs in these complex areas, even if the AI doing it uses a ton of power. It's about beating current human performance in those subjective tasks first.
That's interesting. So a really power-hungry AI, let's say, that could consistently write significantly better strategy reports than a whole team of analysts that would fit.
Under this first option, yes, even if it's expensive to run.
Okay. So what about the second option Dr. Fradelos gives us?
Option two, right. This one shifts the focus. It's more about practicality, efficiency. It says comparable results for analysis and/or synthesis tasks faster with a measurably lower energy cost. So here, the benchmark isn't necessarily being better. It's about getting similar results, but doing it quicker and using less energy.
Oh, okay.
This really speaks to, real-world AI applications, optimizing things, managing resources.
Makes sense. Sometimes just being as good, but way faster or cheaper is the win.
Exactly. It's not always about totally outperforming humans. Sometimes it's just doing it more sustainably, more scalably.
Yeah, I can see that. In many industries, a tiny bit better quality might not be worth a huge jump in cost or energy use. Efficiency rules. And the third option is just.
Or both. Simple as that.
Right. Better qualitative output and more efficient. That's the gold standard, I guess.
That would certainly qualify, yes.
Yeah.
Now, there's another crucial part here. It hinges on what he calls exceptional human intervention.
Okay.
He clarifies this isn't constant tweaking. It's only needing to sort of reorient the software in mathematical situations that break its approximations.
Yeah, okay, let's break that down a bit. Exceptional human intervention. So it's not about constantly babysitting the AI.
No, not at all.
Or fine-tuning it for every little thing. It's more about when the system hits a fundamental wall where the underlying math model just doesn't fit anymore.
That's a good way to put it. Think about a sophisticated weather model. Usually its algorithms work great, right? Accurate forecasts. But then maybe there's a totally unprecedented storm system, something way outside any historical data it trained on.
Okay.
That might just break its predictions. They become unreliable. Exceptional human intervention then would be like a data scientist stepping in, reevaluating, maybe adjusting the core mathematical assumptions of the model itself to handle this new kind of event.
Ah, I see. So the AI isn't just failing randomly. It's hit a situation where its basic understanding, its programming based on the past is just not enough.
Precisely. It's hit the boundary of its mathematical framework.
That clarifies it a lot.
Yeah.
And Tweesy, you mentioned something really interesting. He says this software can even generate its own tasks toward the final goal, potentially even moving towards general AI.
That's right. Which implies a level of autonomy, doesn't it? The AI isn't just sitting there waiting for commands. It could proactively figure out, okay, to reach the main goal, I need to achieve these sub-goals first, and then pursue them. That's a more advanced kind of intelligence.
Definitely. Now let's tackle evaluating those qualitative results. This feels like the trickiest bit. It's subjective, right?
Yeah.
How does Dr. Fradelos suggest we figure out if an AI is actually producing better qualitative stuff?
Yeah, that's a really key question, measuring the subjective. He proposes that the main metric is recognition by the final software users within the same professional culture.
So the people actually using it in that specific field.
Exactly. And that recognition could show up in different ways. Maybe the software just gets adopted widely in that industry, or it gets great results in user polls or high rankings in, industry evaluations.
So it's basically a kind of professional peer review almost. If the actual experts and users in a field agree the AI's output is genuinely better qualitatively, then it meets that standard.
That's the idea. But, and this is important, he also notes that this perception is constantly updated.
Ah, right, because standards change.
Exactly. What seems amazing qualitative output today might just be, the expected baseline tomorrow. As AI gets better and our own expectations rise, it really underlines how dynamic this definition is. The bar for what counts as AI keeps getting pushed higher. And he also brings up a fascinating point about the future. He suggests we might see a shift in many fields away from relying on sort of empirical rules or gut feelings.
Towards more scientifically proven principles.
Yes, which could actually mean fewer purely qualitative tasks over time as more things become governed by hard data and evidence-based approaches.
That is a thought-provoking idea about where professional work might be heading. Okay, what about the other side? Quantitative results, he mentions those are transparent today. That seems much easier to assess.
Oh, definitely. With quantitative stuff, we're usually dealing with clear numbers, right? Things like accuracy in calculations, how fast data gets processed, reduction in error rates. It's much less ambiguous when you're just looking at the figures.
Clear metrics.
Okay.
Now, the energy cost comparison. That's a really interesting angle, especially for that second option in the definition. It's not just comparing a server farm's electricity bill to, what does it compare to?
This is where Dr. Fradelos adds something quite novel, I think. He specifies the energy cost comparison must be conducted scientifically. Fair enough. But crucially, he says, the energy cost of basic human metabolism must be taken into account.
Human metabolism, like the calories a person burns.
Essentially, yes. So we're talking about a fundamental comparison. The energy a human professional expends doing a task versus the energy an AI consumes to get a comparable result.
Wow.
It puts AI efficiency in a much broader context, doesn't it? It considers the actual biological energy cost of human labor.
That really shifts how you think about AI efficiency. It's not just tech optimization, it's a fundamental resource comparison with us, with humans. Okay, let's talk about learning, exploration, hypothesis generation, and testing, adaptation. These always feel like core parts of intelligence. How does his definition handle those?
Well, he defines these processes as tasks that can be either hardwired into the system or generated by the software itself. But the critical point he stresses is that the level of learning must serve the final goal.
Goal-oriented learning.
Exactly. He draws a line between AI systems focused on achieving a specific outcome, using learning to get there, and systems that are maybe only focused on the learning process itself. He seems to view those latter ones more as AI software under development.
Ah, okay.
Implying that true AI, by his definition, uses learning strategically to reach a specific goal.
So it's not just can it learn, but how effectively does it learn to achieve something defined? The intelligence is in the strategic application of learning and adaptation.
That seems to be the gist, yes.
And what about just generally intelligent software behavior according to this definition? What makes software seem intelligent?
He offers a pretty pragmatic take here. Software behaves intelligently if it saves time and RAID door if the results are substantiated.
Simple as that.
Seems so. It's about tangible benefits, either making things quicker, more efficient, or producing results you can actually trust and verify.
And he also mentions the level of intellectual challenge and how that affects how we perceive an AI's quality, even bringing up efficient sorting algorithms as a kind of basic AI.
Yes, and that acknowledges that AI isn't monolithic, right? It exists on a spectrum. Even fairly simple algorithms that are really good at solving one well-defined problem efficiently, like sorting data can be seen as AI, just, at a lower level of complexity or perceived challenge compared to systems tackling those really tricky qualitative tasks we talked about.
And the perceived quality, as you said, ties back to that professional recognition.
Exactly. It's all linked.
Okay, so we've really dug into the details of Dr. Fradelos' updated AI definition here. Now, let's maybe pull back a bit. How does grappling with this kind of definition help you, the listener, make sense of the AI landscape now and, well, going forward? What are some implications for different professional fields people might be in?
That's the key question, isn't it? Connecting it back. I think this definition really pushes us to look past the hype that often surrounds AI and focus instead on its actual demonstrable impact. Can it produce genuinely better results in complex qualitative work results recognized by experts in that field? Or can it achieve comparable results but with major gains in speed and energy efficiency? And that efficiency calculation now includes potentially the human energy cost comparison. So this definition gives you a framework, really, for evaluating the true value AI brings to the table.
So for professionals listening, it means maybe looking at AI tools more critically, not just how technically sophisticated they seem, but what tangible difference do they make to the actual work?
Absolutely. What outcomes do they deliver?
Yeah. It also really highlights that dynamic nature we talked about. What seems like breakthrough AI today could just be a standard tool tomorrow, which means we need to stay flexible, maybe focus more on the results than just the label AI.
Couldn't agree more. And that energy cost piece, that introduces a dimension that's only going to become more important, right?
Yeah.
Especially with sustainability concerns rising. It nudges us to think about the environmental footprint of AI along with its capabilities.
Okay, so let's try and summarize the key takeaways from Dr. Fradelos' updated definition. It seems centered on demonstrable results, either superior qualitative outcomes, judged by professionals in the field, or comparable results delivered faster and with lower energy use, maybe even considering human metabolic costs.
That's a core part.
It emphasizes goal-oriented learning, not just learning for its own sake, and it accepts that the boundary of what we call intelligent is constantly shifting.
Precisely. It offers a practical, almost pragmatic lens for viewing and assessing AI progress, focused on tangible impact and efficiency.
Okay, and that brings us to our final thought for you to mull over. Thinking about this definition, this focus on results, efficiency, professional recognition, what existing software tools out there, tools we might not usually label as true AI, might actually already meet these criteria in certain areas? Are there things quietly outperforming or matching human capabilities right now, either in efficiency or recognized quality? And maybe more broadly, what does this constantly shifting understanding of AI mean for how we integrate these powerful tools into our work, into our society? And, well, what are the ethical implications of that moving boundary?
Definitely something to think about.
It is. Thanks for taking this deep dive with us.